Okay, friends, let's start. Welcome everybody to this talk about talks. This is going to be carried out by me and Remco. We schedule an hour and a half. Maybe we need more time. I will talk about the structure in a second, but we're going to have an interactive part. And maybe depending on interest, we might meet again in a couple of weeks to hear you present. We can even give you more feedback. The reason why this entire thing came to be is because as part of the scientific community and professional people in general, you're going to be required to do this stuff. Some people love it, some people hate it. The idea of this is that if you hate it, maybe we can find ways in where you feel a bit more comfortable and you hate it a bit less. And if you like it, I hope that Remco and I can talk about a couple of things at least that could be used. So this is the outline for today. And I'm going to be showing you the QR code for the slides. I am recording. The same rules apply for the Meet a Professor, Meet a Scientist series. If you have questions or anything that at the end you don't want it to be part of the recording, I'm very good at editing, so I can take that out. But for now, I'm recording for future generations. There is a link to the slides. We're going to have a practical example in where I am going to act as two different people, not at the same time, but one after the other. I will give a bad presentation for 3 minutes and a good presentation for other 3 minutes, or what I believe is good and bad, and then we're going to analyze that together. Then Remco is going to take it for the foundations, touching upon the many important things that if you have never given a talk or you have given very few talks, these are the basic things that will be important for you to focus on. Then I'm going to talk about next levels, things that you can do to make flashy impacts on your audience. And then we're going to close with some takeaways. Before we start, about the flyer though, I think most of you, if not all of you, saw the flyer, and almost everybody that I asked, I don't think really understood what the flyer intention was. Look at the flyer for a second. Do you feel anything when you look at this flyer? Andy, what do you feel?
Remco's name is spelled wrong.
Remco's name is spelled wrong. See, yes, here. But in here it's spelled correctly. My name is spelled wrong. Yeah, but in here it's correct. So thank you. What else? What else do you feel more than the correctness? Huh? You feel calm when you look at the entire thing? It could be something that is folded. Any more thoughts, Daniel?
When I look at this, my eyes immediately go to the right, and I just ignore the left side.
So funny, if you actually read what is on the left, is a bunch of garbage. That tells me that nobody read it, so point proven. It was written between me and ChatGPT and a drunken ChatGPT. There is a parenthesis here that opens and doesn't close. A bunch of references that go nowhere. It's a mess. The idea, the intent was to say, this is a good way of transmitting a message. This is a bad way of transmitting the message. This is where the time and the location are. The time is even wrong because it says February 30. So I recommend that you go over. It has a lot of Easter eggs, but you see, nobody or almost nobody realized because it's so bad that you just skip it. You just go directly to the right. So, keep this in mind for messages in general, flyers, presentations, papers, etc. Okay, that was the first thing. The second thing, this is a disclaimer about what you're about to see and hear. I want to think of this in a very abstract way as the presentation manifold. You can imagine this surface in multi-dimensions with all the different choices that you could make on how to make your slides. This thing is plagued by local maxima and local minima, sadly. There's many ways of giving a good presentation. So many of the things that at least I'm going to show relate to my personal taste and my personal style. If you don't resonate with that, that doesn't mean that your presentation is going to be bad in comparison to mine. You can have two different presentations that vary very different in style, and you can see the cartoons on the top, which is the usual thing that I do, and both deliver the message in a good way and people can follow. So remember, this thing is going to appear later. Okay, we're going to start with the bad talk, good talk example. It's about the same topic. It's about calibrating the liquid drop model for the mass formula for binding energy. I'm going to give 3 minutes of each. I realize I don't have my phone, so I will do my best estimate for that. And I recommend that you try to spot as many bad practices as you can in the bad one. I hope not that many in the good one. Vice versa, and we're going to discuss them after. And I'm doing this. I really have to change characters.
Who are you?
Uh-huh. Okay, we're ready. Where is the... Good morning, everybody. Today I'm going to be talking about calibrating nuclear binding energy theoretical model using the semi-empirical formula. I'm Pablo Giuliani. Hi. Scientists investigating atomic masses in the early 20th century noticed a small but consistent difference between the sum of mass of the nucleus and the actual mass of the nucleus. Einstein mass energy equivalency equals mc squared. Explain this discrepancy as energy that holds protons and neutrons together. As of precise mass measurement using the mass spectroscopy revealed how this mass effect varies among isotopes. Isotopes are different nuclei that have different numbers of protons and neutrons. For example, in here you can see that the binding energy of oxygen, which is 8 neutron and 8 protons, is 71.80965. This insight led to the concept of nuclear binding energy, quantifying the energy needed to disassemble the nucleus into its constituents. Subsequent research built upon these findings, shaping our fundamental understanding of nuclear stabilities and reactions.
Pablo, ¿me interrumpes?
Yes.
En la figura anterior,
Ajá.
¿quién es el científico que tiene?
Ah, mira, este es Aston, es un científico, no recuerdo dónde era, creo que es de Europa, pero él es muy importante porque él hizo estos descubrimientos sobre binding energy y basado en ese trabajo es lo que nosotros estamos haciendo acá. De hecho, EFRIP lo construimos basado en esto. Yo estoy diciendo un montón de tonterías, pero nadie entiende español. Entonces, en el fondo, tú eres la única persona que me está entendiendo. Y estos números son muy importantes porque este 77 ellos lo midieron en Canadá y nosotros estamos tratando de hacerlo diferente.
Vale.
¿Tiene sentido?
Vale, sí,
Gracias,
muchas
Juan.
gracias.
¿Alguna otra pregunta? Okay. Theoretical model. So, if you have the time-dependent Schrödinger equation, that is this equation there, we can write R for a three-dimensional position vector and B for a three-dimensional momentum vector. The position space Schrödinger equation relates. There's actually many ways that you can solve the Schrödinger equation. You can use separation of variables. You can use the finite element method, the harmonic oscillator basis expansion, and you can use the variational principle. And in this work, we use the semi-empirical mass formula, which is a formula for writing the nucleon and the protons as a function of the binding energy, and it's here. Okay, my results. The first thing is that when running, we wrote a Python code that can actually do the least square fit, but it raised this error. So, and at the end, I understood that it's because I was passing the wrong way, the wrong variables. So it didn't land well. So I guess this Python only responds to correct indentation. So at the end, we were able to make it work, and you can see that the fitted model reproduces the data point used to fit the model. So you can see it in here, that is the data and the model. And the Python function curve fit from SciPy gave accurate results. And these are the data. So for oxygen, we got 126.4423.468, but the actual data point is 127.6193.152. But for oxygen 17, I don't have time, sorry, I have to skip the next slide. So I guess she was actually charmed, the Python. Anyway, switching gears. So neutron stars are one of the densest objects in the universe, and they form an ideal proof to theoretical models to test the limit of understanding of quantum mechanics. The equation of state forms an important piece of the puzzle. The laboratory observables for late LIGO and answer observations of neutron star masses, and here I'm presenting the formula for the log number, and it should be possible to calculate the equation of state of pure neutron matter using the liquid model we developed in this study. So conclusions and future work. Yeah, I run out of time, but the agreement between experimental data and the liquid drop model developed is very exciting, and it will allow us to advance our understanding of this new era of rare isotope. Thank you. Any questions? Yes?
Well, I couldn't see the photo on the two-side fact.
This one?
Yeah, I can't.
That is an arrow.
Okay. Very good. Okay. Okay. That's
Any
it.
questions? Okay, that was a good presentation. Now let's go for the back. That was really hot. Thank you. All right. Welcome, everybody. Good morning, good afternoon. My name is Pablo Giuliani. I work at the Facility for Rare Isotope Beams, and I'm going to present to you about the work that I have been doing there over the summer. The title of my talk is called Nuclear Droplets, Modeling the Nuclear Binding Energy as a Liquid Drop. This is the outline of what I'm going to talk. It will be around 3 minutes, but I really wanted to show you what are the different steps. I'm going to motivate why we're doing what we're doing. We're going to discuss the theory. I'm going to show you the results of what we have obtained, and then I'm going to close with some key takeaways. As a motivation, because I don't know how many of you actually have worked on nuclear physics, this is an atom with all of its electrons, and usually we don't care about the electrons, we focus on the nucleus. And the nucleus is made out of protons and neutrons. How they stick together is actually the topic that we're covering. It's called the binding energy, and you can imagine this as some sort of glue that is making protons and neutrons basically stay in the same place. To give you a scale, in case you have never seen this number, it's around 10 MeV. And if you were to disassemble all the calcium atoms in your body, that would take around 10 to the 15 joules. That is around 10% of the energy that was released in the Arizona crater. So just to give you a scale, that is a type of magnitude that we're talking in terms of nuclear physics. That doesn't mean that you're a bomb. That is the amount of energy that I will need to disassemble your calcium atoms. This is extremely important for the things that we do at EFRIC. In particular, the binding energy plays an important role on determining whether certain types of decays are allowed or not. It plays a role in nucleosynthesis, how you can actually make isotopes in the stars. It plays a role in understanding shell evolution. And there's a thing called magic numbers that changes depending on whether or not your nucleus is formed. And finally, it's an important piece on the application side. In terms of nuclear medicine and nuclear energy, you cannot get away without understanding this. So if you look at the landscape, this is a nuclear chart, you can see how the binding energy changes across it. And what we want, this is the goal, is to use theory to explain the behavior that we already see and to predict the places that we have not made an experimental observation yet. That's what we are after. So in terms of the theory, the theoretical model, if you actually try to solve the Schrodinger equation, which is a problem for a many-body quantum system, it gets extremely complicated if you need to treat interactions between protons and neutrons. Instead, the approximation that we're trying to use is we treat the whole thing as a liquid, and that's why we call it the liquid drop, and we expand the binding energy, this glue, in 4 terms. Each one of these has a physics underpinning. The first one is a volume term, should be proportional to the number of neutrons and protons that you have in there, the total amount of glue that you have used. There is a negative term correlating to the surface. The more surface, you will expect that the thing is less bound. And the next 2 terms is a Coulomb term because protons don't like each other because of the electric force. And a symmetry term, that's a bit more complicated, but has to do a bit with quantum mechanics. Once you have your model, these are all parameters that we need to feed to the data, and these are my results. Once you do that, this big formula, details of matter, you end up obtaining these numbers from your experimental fit. And when you compare that to your experimental data, the model, they agree. An average error of 3 MeV is excellent for a scale of thousands of MeV. If you look at it in a different way, if you plot the binding energy per nucleon, you actually can understand this model, can use this model to understand why light nuclei fuse and heavy nuclei fission, because the maxima is around the iron peak. But if you focus, for example, on calcium, you start noticing some interesting patterns. You see that the theory in blue always under predicts what the experiment is showing you. And you also have this zigzag effect in the red points. If you show that in the entire chart, you start seeing a pattern that emerges. Do you know what these numbers are? Those are the magic numbers, exactly. And those relate to quantum mechanics. Quantum mechanics is kind of magic, so that's why we basically label the magic numbers, and that is a deficiency of our theory, but that tells us the next places that we would like to look for. So, as a few takeaways, the first one, I hope that you follow me, that this thing is important for many applications. The liquid drop model that we created is not terrible. 3 MeV of error is actually appreciably good, given that we didn't use quantum mechanics. And the final is that we have a pattern that we cannot explain unless we bring back some of these aspects of quantum mechanics. With that, I would like to thank the people that funded this work and my collaborators. Any questions? So that was a good talk.
I just feel like clapping at that one.
Go for it. So before I give it to Remco, we're quickly going to go together through the slides of the bad one, and you can tell me what the heck went wrong. Any ideas on the first slide?
First thing, I can't really read the text because of that.
This is a gorgeous colors. Doesn't help. It's just distract. You cannot read the text. What else? In this intro slide that is bad. Curtis.
It's a very verbose title, and it's kind of just up there in the corner.
Very non-memorable title. Do you remember the title of the last one? Of the good one? Anybody remembers? You see? At least a part of the audience remembered it. This is something that nobody will remember. Spencer.
You haven't formatted the slides into a particular format. For example, like the F-grid format that we use, or we use it for a reason.
Yes, neither of them use it every template, and that is something that you need to discuss with your advisor whether or not you want to use it. But this format is horrible, and it's not even caught well. There is no my name. My name is the thing in the center. No F-grid logo. Nobody knows where I'm working at. I don't have an email that somebody could contact me. What about this? Binding energy, and I have this dude that has done an experiment. Please go ahead.
Wall of text.
A wall of text. And a wall of text, sometimes that is needed and is important. This one has nothing to do with anything. Why do I have the E equals MC squared? I mean, that is relevant if we were having a class, but for a 3-minute presentation, no. Spencer.
Who's the guy on the top right?
Aston something. I don't even define it. I didn't even put the name, but it's one person that made one experiment about nuclear masses. Right.
And whenever you, on the first slide and then transition to this slide, you kind of just looked at this. First, you look at the computer screen.
Uh-huh.
Look only at the slide. And
Yeah.
Back of the audience.
And it's,
Exactly. Yeah.
what else did I do wrong? Somebody remembers a very bad thing that I did? Magda.
Didn't you explain to Juan who is the guy?
I did explain to Juan who is the guy.
Yeah, you did.
So I completely ignored the fact that I have an audience of non-Spanish speakers and I started fighting with somebody. Thank you, Juan. That was on purpose. I requested that. What else is wrong in here? I don't know about you, but I see this and I cringe.
Yes.
And this is so easy to fix. I will show you later how. Honor.
It's not clear if this table on the right is either your results or someone else's, and if it's someone else's results, there should be a reference.
That is true. Why are these numbers important? By the way, they're wrong. If you see the table on the other, these numbers are wrong. But no units. VE, what is VE? What about this one? Who can tell me what is wrong with this? Eric.
On the previous slide, like, this is a horrible way to present data by itself. Just
Yeah,
tables.
terrible. Curtis.
Just want to note all the the white space around the image is being used for the background, and then the white space around the guy's portrait that's not even centered in the white space.
Yeah, it's horrible. What about this one? Because what is wrong with this one is a bit subtle. By the way, you notice that I changed from this very dark background to a more light one because I don't want to continue focus on that. I already know that I screwed that up.
One more on previous.
Yes. Oh boy.
The image of the atom isn't even referenced; it's just there.
Yeah. What is the use of that?
So transparency issues aside, it just is there.
Definitely. What about this one? Why is this wrong? Because this is subtle, but it's extremely important. Josh.
There's no connection between the top bit and then the bottom equation.
Why I'm even talking about the Schrodinger equation? Why I'm telling you that that you can solve the equation using these numerical techniques? I don't even solve the Schrodinger equation for the problem that I'm showing you. In the good presentation, I mentioned, you could solve the Schrodinger equation. It's very difficult. But there is no, all of this doesn't play any role on any of my results. Thank you. That is the important part. Yes?
So I suspect that this white cutout here, that wasn't that came from Wikipedia.
A screenshot of Wikipedia with a reference.
That did, and you haven't cited that you got that from Wikipedia. Isn't that plagiarism?
But yeah, you should put me in jail. I agree.
You jumped to show what equation you're talking
Yeah, and I lost my hat, which Cal gave me that hat. Don't tell him that. But yes, it's the type of things that is like, I probably can do. What about my I put a lot of, George, go ahead.
I think that was the beginning. Just the hat and the shirt was not supposed to be there.
Definitely. And the shirt, this is cake from this morning.
That's for the hammer.
So be careful how you're dressing because it can make a huge impact. Okay? What about this? Please.
Not about this, but more about your body language. You were like just hunchback. You were also just like going back and forth with your arms, showing you were nervous.
Good.
And then
Serious.
and your change of tone when you're speaking, right? You're very low, but then you go high and you go a little more low. So it's kind of hard actually to hear you.
Yeah. I got nervous. I seriously got nervous. I started doing all of this. This is going to sound very arrogant. I don't remember when was the last time that I got nervous giving a talk. Probably when I was a grad student. For the last 5 years, I just feel like I started doing this and I started feeling my pulse rising and I got seriously nervous. And that was not me going in character. part of the body language and everything that you do traces you to that direction. So yes, thank you very much for that observation.
I think maybe more of a subtle thing too. Whenever you're walking back and forth, you were dragging your feet.
Yes.
That was making noise.
Yes. Thank you. Curtis.
Another one I noticed was, so you not only, okay, having to cut out from Wikipedia or a textbook or something, not only having it, but you read it. You're reading basically from a textbook.
Yes. I was reading. All right, what about this one? What is wrong with this?
No one wants to see it.
Nobody wants to see code that doesn't work. Why am I even wasting your time with that? What is wrong with this?
No.
Jokes are hard. Renko will talk about this more, but not necessarily is like, not everybody can pull it off very well. And I'm really glad that nobody laughed, at least at the beginning, because if you started laughing, I was going to lose it. And then a bunch of data doesn't make sense. This, no, you cannot read anything. It doesn't even have labels, doesn't have units. Terrible. This concludes, no, awful. And the jokes again, with a different font. Switching gears. This has been something that I have seen so many times in so many talks. And every time that happens, it's supposed to be, let's say, a theory seminar that should last for 40 minutes. We're in minute 43, and the speakers does this. Okay, now switching gears to, I'm like, no. Very, very bad. The picture is awful. The change in style, just everything. Conclusion, same problem.
Does it have anything to do with what
No.
was going on before?
Well, it should be possible to extend the liquid draw model to calculate the equation. This is not true also, but this is supposed to be the connection with what we're doing. Please.
I think someone asked you what that was, and you said that was an atom. Isn't that neutron star?
That is a neutron star, of course. Yes.
Good. I couldn't read it, but I was like, that's a neutron star.
Of course it's a neutron star.
Okay,
Yeah.
good. Okay.
And none of this makes absolutely any sense. And oh my goodness. I showed this to my mom and she was like, oh, Pablo, please don't. So hi, Mom, I'm recording this for you. Okay, what about the good one? Again, taking away style. If you don't like the style, that's completely fine. But any things that you can take of this that you thought were better? What about the title? You can remember the title. You can even have two. You can have a more informal one that is easy to remember and what the thing is about. And did you wanted to say something?
Oh, next slide. Okay, so I don't know if this is a style thing, and maybe you can explain it to me. Every presentation I've ever seen has like motivation theory or results takeaways, but like when I'm going to a physics talk, I know that that's going to happen. So is that a bad choice or is that just a stylistic choice?
It's up to you.
Okay.
I think having an outline is very useful.
Okay.
You can structure it in a different way, but none of this is prescriptive. Okay. It's not that you should do this. This is an option of doing way better than the first presentation.
Okay, sorry. Yeah,
right.
I think it's a very positive thing starting out your presentation, looking at the audience. Like your intro, you said who you were, you read your title, and then you're very, with your hands, addressing the audience rather than looking at your screen. So how you started out the talk kind of.
Thank you. You saw that I defined who I am, where I work. There is my email. If you were so impressed by my talk and my results, you can email me and invite me to give them to you. The other, nobody knows who they will be. Okay, outline, motivation. Again, this is my style, but this to me is important, is to try to make this relatable to the audience. The way that I think of this is I'm going to take you on a trip on a forest, and I'm going to show you very pretty trees and a waterfall. First, I want to tell you beforehand so that you know what we're expecting to see. But second, I want to make this relatable. Otherwise, I will be like, oh, and that tree is important. And we continue walking, and you don't take anything from it. Relevance, why this is important. What exactly are we after? The motivation, I have one equation in the entire thing, or two equations, at least some understanding on what they mean. And results, focusing on discussions. See, no tables, no numbers, just the plots and interpretations on the plots. And then there is a mystery. But what is the next thing and how we're going to fix this thing? And the takeaways, which is things that people can remember. They can take away with them. And the acknowledgement, which is extremely important. Somebody paid for me to do this, or many somebodies, and some people actually helped me in building this. Make sense? Any final question before we go to the Remco part?
Yeah, we changed the photo.
Yeah, they did. And they revoked it? Oh, well. Yeah. Okay, well. Very good. Okay, now we go to Remco. Thank you. And here you go. For you.
Right, thank you. All right, so so my name is Remco Zegers. I don't think I know everybody in the room, so but I work here at the lab. I'm basically trying to give the interface between the first presentation that Pablo gave and the second one. So to pull off a presentation that Pablo gave as the second one is actually really hard. I can't do it. I mean, I don't give presentations like that. That's why Pablo is doing the advanced section of this presentation, and I'm doing the foundations, okay? So the talk I'm gonna give is the one I wish I would have had when I started out giving presentations. The way I found out I give really poor presentations when I was a graduate student is we had a school and they decided to record all the presentations of the students and then thought it was a good idea to play the video in front of everybody and let everybody shoot at it. And so that was the time when I realized my presentation style wasn't very good. Okay, so I'm gonna cover a lot of little details that I think can help you give you a good presentation. It will not necessarily get you to what Pablo just showed, okay? And I think it's actually quite important before you give a talk like Pablo just gave to make sure that you have the foundations correct. So that's what I'm gonna try to cover. All right, so as Pablo already mentioned, and you will see many of the things that just popped up in the presentation that I will give, you will recognize them in a slightly more boring way, but nevertheless important. So different people have different styles. So I cannot give a presentation like Pablo. It would be very difficult for me. I have my own style. That's perfectly fine. Different presentations have also very different requirements, right? If you give a presentation for a general audience or you give the 10-minute APS talk, it's a completely different presentation. So you have to tune it for what the purpose is. Some people are very good at speaking publicly. Well, Pablo speaks very well in public, practiced a lot, right? Some people it's very hard. Some people are introvert. They give a presentation, find it really difficult to just stand up and do that. But I can guarantee you, if you practice, you'll be able to give a good presentation, right? It's a matter of practice. When you're giving your first presentations, take your time, make sure you have the details correct. The first presentation doesn't have to be a flashy presentation. It has to be the one that is going to win you the Nobel Prize, right? But it has to be good. I definitely recommend going to many presentations. Actually, sometimes I'm surprised. I go to a student who's giving their first guidance committee meeting, and they don't know what a guidance committee meeting is. Like, have you not been in a guidance committee meeting of some other student, right? So very important to go to other talks. Final, if you give presentations, even at group meetings, treat it like one that is for a general audience. Practice during the group meeting. Of course, you can put some slides together and it has some graph, and you don't necessarily have hours of time to prepare for every group meeting. But there's things that you can do to help prepare yourself. Making good figures. If you practice how to do that, you can do it every time, right? So many different presentations. I'm not going to cover all of these, but it would be impossible. But just to say that they can be very different, okay? And I'm not saying one is easier than another. Some you will practice more because you will probably give more scientific presentations than public presentations, except for a few. So different types of occasions require different presentations. Another very important thing, giving a presentation is like telling a story. Okay, you have to get from A to B. You want to deliver a message. So what is the message that you want to give? And this is what the laboratory director sometimes says. What is the story that you're going to tell? Tell the audience what you're going to tell them. And you tell them, and then you repeat what you just told them, right? If you want to give a message, that's what you're doing in a presentation. And if you're having slides that do not contribute to the delivery of this message, you should think, why do I need this slide? I don't really need this slide. It's an interesting side story, but really, do I need that information? Also, if you have a good story, there shouldn't be any plot holes. If you get from A to B and you don't understand how you get there, that's not good. People have to, in order for them to understand the story, they have to have every bit and piece. Now, if you give a 10-minute talk or a half-an-hour talk, you have different levels of detail. But the main parts should always be there, right? So no plot holes. Very important. So how can you be a confident speaker? And I think it's very important to know what you do not know, right? And avoid adding items to your presentation that you cannot explain. Very common, right? somebody might say, oh, this research is important for astrophysics, but have no clue why that is the case. And somebody can ask, and then it looks silly, right? So you want to make sure that whatever you put on the slide, you can have something reasonable to say about it. Otherwise, just don't put it, right? You don't have to impress anybody. This is more a tip if you give your first presentation. Focus on what you have worked on, rather than describing the Schrödinger equation that you never used or the code that you never used. Focus on the stuff that you know about. You can answer questions about things you know about. That's how you feel confident about a presentation. Be precise. So make sure what you say on your slide, what you say and what is on your slide, it's correct. You put stuff on there you're not quite sure, and somebody asks a question, that's not good, right? Make sure that it's correct. This one is very, very important. Be complete. So refer to work by others. In our field, it's not that big. Co-authors on paper might be in the audience. It's not unlikely. People get upset pretty quickly, right? And also, if you refer to papers, please read them, right? So that if you get a question about it, you actually know why this is an important paper. Being aware of what the strengths and weaknesses are in your research. As no other, you do some research. Analysis, there's this little piece, this is not great, there's an issue with that. You should be aware that if you get a question, you have an answer ready. I'll say, yeah, well, I didn't know what I was doing. That's not good. And this one is very important. Don't try to answer questions that you do not know the answer to, right? And sometimes people think, well, I should answer something, but it's better not to answer if you're not sure. Just say, and if you give a talk and you get 10 questions and you don't know how to answer any of these questions, you've given the wrong talk. That means you did not focus on stuff that you know well, okay? Then you've given the wrong talk. It's perfectly fine not to know the answer, right? And so it's okay. So that helps you to be more confident when you're speaking, if you're not a confident speaker. Practicing. Okay, so this is important. There are many ways to practice. You can do it with a group of fellow students or friends or the mirror. Very painful. I find this very painful. You can record it. As I mentioned, you can record it and look back. Very painful, right? But you will know what works well and what doesn't work well when you look back at yourself. Make sure to practice seriously and do so sufficiently in advance. You do it a day in advance, it's probably not going to be very helpful. It will help a little bit, but it's not. You won't be able to make many changes. Make sure you have enough time. Now, this advice is very different. So in Pablo's presentation, he had, 10 slides in 3 minutes, maybe even more, many transitions. I would not advise to do that for your first presentation or your first few presentations, okay? It's very hard to do this. 1 minute per slide. If you give a presentation, for some lab reviews and stuff like that, the lab director will tell you no more than 1 slide per minute. Just take it out. Again, this is a typical time structure, 20% for introduction, 70% for main content, 10% for summary and conclusions. You want to try to get to the conclusion, not like running out of time. Look for plot holes and unnecessary details. So is there something missing that's critical to understand the story you're telling? How often have you seen a presentation and somebody says, oh, I forgot to mention, and then it was a very important detail, right? And it goes 3 slides after you really needed it. There's too much details, it's not helpful. People won't, be able to absorb all the details. You can create some backup slide for details, that's very helpful. So this is for answering questions that you might anticipate. Last minute changes to a presentation, probably not a great idea. This sometimes happens in a conference. You listen to a talk which is on a similar topic as yours and say, I know this answer, I'm going to put it on my own presentation. Not a great idea. If you tend to feel nervous for a presentation, though this comes with experience, right? If you're just giving presentations, you can memorize a few sentences just to help you get going. It's not a bad idea. Usually once you get going, this makes it much easier. You want to avoid completely memorizing a talk. That's not great. Because if you do that, it doesn't come across as natural. If you get a question, you probably cannot answer it very well. So try to avoid memorizing a whole talk. So some details. So dress and demeanor. So as Pablo showed, You want to wear something, you want to be respectful, you also want it to be comfortable. If you wear something that you've never worn before, maybe not a great idea. You can show some personality, it shouldn't distract, from the presentation itself. In our field, it's not so common that you have to wear very formal attire, right? But it's better to overdress than underdress. Important, anticipate the use of a clip-on microphone or slide advancer. So if there's no good place to put the microphone, then it sits somewhere and the sound is not quite good. So that's important. Be enthusiastic about your work and the opportunity to present. If you're not enthusiastic, why should the audience, right? Don't be negative about your work. This actually happens quite often, where people give a presentation, they get a somewhat critical question, and then they start to downplay their own result. No, you give the results, you worked on it. Maybe there's something that can be improved and you can talk about it. You don't want to, be negative about your own work. At the same time, you don't want to oversell the results, right? You can and should explain the impact of an outcome, but when you say something like this is the first, actually we had a seminar recently, right? Somebody said this is the first time, audience, somebody spoke up and said, this is not true because, and then there was some detailed reason. So if you say something like that, be sure that's true, and also be sure to provide the necessary qualifiers. Okay, so don't oversell the results. So you are here, right? I'm happy you're here. It's important you're here. Treat your audience respectfully. The other side, if you get some criticism or a scientific question, understand that this is not, well, it shouldn't be aimed at you personally, right? This is part of the scientific debate. You get a question, maybe critical, but that's okay. In the end, getting questions from the audience is a good sign. That means people are engaged, right? If you give a talk and you said, well, any questions? And then there's no reply, then did they actually understand what I was talking about? Take time to answer the questions, make sure you understand the question, and if you can't answer, that's okay, right? Just say, I'll get back to you, not a problem. This is, as Pablo showed, be sparse with jokes and funny slide elements. They should be functional. Telling a joke is great, makes the atmosphere a little bit different, but it's very rare that everybody likes to joke, right? There's 40 people here. If I tell a joke, some people say, oh, that's a silly joke, right? And now you're turned off by the presentation I'm giving. So you should do this. It's okay to make a joke, but don't overdo it. This one is actually quite important. If you get, it sometimes happens, if you get a comment, something that's disrespectful, you say, just be prepared. What am I going to do in a situation where somebody tells something that's really inappropriate? You can say that's inappropriate, so this is not a time to discuss the issue. Just make sure you're prepared for that. It happens occasionally. It's rare, right? And then, thank the audience. Some details. File formats and fonts. This is another one. I didn't used to do this, the first one. Make sure that you have a complete version of your talk. And the only time I did it because I was in a plane to Japan. I had to give a talk the next morning. My laptop broke in the middle of the plane. I had no presentation. Panic, right? So now, whenever I go, before I travel, I have at least a complete version. Yes. What do you do? I found a laptop, a computer somewhere very early and got no sleep when I arrived in Japan. So I solved it. But when it's better to have a presentation, you travel much more pleasantly, right? You don't have to worry about it. Have a version of a presentation available in different formats. Many conferences now tell you what the format is, but PowerPoint and PDF, everybody knows a Mac and a Microsoft doesn't quite work together well. So making sure that you're confident it's right. Bring a presentation on a memory stick or put it somewhere online where you can get to it. Another good one, try to use well-known and widely used fonts. You see a presentation, somebody puts it on the computer, and all of a sudden the fonts have changed because they use some odd font and it was replaced by where you see it all the time. You can embed the fonts in the presentation if that's possible. And then you want to try out your presentation on the actual computer you're giving it with. I guess we kind of broke that rule because I sent my presentation to Pablo. We didn't check it afterwards, but If you give a talk at a conference, you want to check that it looks okay. Sometimes they have some testing room. Yes.
Yeah, this is an issue I've had a lot, especially with images. Like it'll look one way on my screen, but as soon as it goes on the projector, it's completely
different, or it gets turned by 90 degrees, things like that. So there's things you want to try to avoid that. Go to the washroom a little before the presentation. Arrive well in advance. Don't walk in the last minute. Little things that you can do. Check out the room. Figure out where you're going to be standing. Familiarize yourself with the equipment. You have a laser pointer, slide advancer, microphone, computer. Test the presentation if you can. Zoom. See it all the time. I mean, we've now been in Zoom land for 4 or 5 years. Still very tedious to get a Zoom presentation up and running. I don't know quite why, but it seems to be difficult. So as Pablo said, clarity of speech is very important. If you have not spoken in public much, please practice in front of some fellow students. Try to face the audience as much as possible. This is sometimes quite difficult, especially if you need the slides themselves to tell the story. And I think it's okay to face the slide a little bit more in a situation like that, especially when you're starting to give presentation. Make sure the volume of the speech is sufficient for the room. Practice the words. I've written the word cosmochronometer. Neshat should know this, cosmochronometer. Before I could pronounce that word in a reasonable fashion, I had to try it a couple of times, even though I wrote it out many, many times, right? Different people have different accents, that's great, but it can impact how well the audience can understand you, so be aware of that. Typically, people tend to speak a little faster when they're presenting, so that doesn't help. So if you know you speak fast, try to pace yourself as much as possible, and then try to react to visual clues. The question, you can respond to it. Okay, so now a little bit about the presentation itself. So this is a sort of, as I said, somewhat standard presentation. So this is in between the two versions of what Pablo showed. So title slides completely agree. It's kind of like a business card, kind of showing something about yourself. It must contain the name, the title, affiliation, preferably with logos. Preferably the right one. The one that I often mistake, I see, so I know somebody's supported by NSF, bang, DOE logo. Okay, if you show that when the NSF program officer is in the audience, not good, right? So you want to know what are the right logos on your presentation. The FRIP standard slide deck doesn't have the NSF logo, right? So you have to do some effort to get it right. You can add collaborators on the title slide if you don't want to put it at the end. If they're co-authors, you can list them. Invited presentations usually have one author only. You can put acknowledgement on the title slide. Again, they can also come at the end. And you can show the logos. You can show some relevant graphics if you like, especially if they help to introduce you to the story. And again, when you present the title slide, it's a good time to thank the audience so that you won't forget it at the end. Introduction. So this should explain why the topic is relevant for the audience and why it matters at all. And you can address some of these questions. This depends a little bit on the talk that you're giving. But how does it relate to the audience? Why should they care about the presentation in the first place? How does it relate to an overall scientific quest? So what we often do is we refer to the long-range plan for the Nuclear Science Advisory Committee, because that kind of highlights all the big things that the community has decided we should be doing in the next 5 years. So if you look at that and say, okay, this really connects to that goal or that goal, that would be helpful. Maybe you can discuss some historical perspective, and you maybe want to give the takeaway right away, right? You can tell them, this is what I'm going to tell you. This is why it is important. You also want to take some time to introduce important concepts for the presentation. And this depends on the audience. So in this audience, you might think, well, everybody knows what a nucleus is. When Pablo starts talking about the binding energies, there's certain things that he doesn't have to introduce. But that depends on the audience. Now, it's common that speakers assume that the audience knows more than they really do. I think this is very common. And then you get statements like, everybody knows, or I don't have to explain for this audience, or this is introductory physics. So how many seminars have we had last year where this has happened? Terrible. I always feel bad. I don't remember my introductory physics, first of all. But this is not helpful. And I'm sure often when this is said, it's not true. It just makes few people bad, right? That's how you get imposter syndrome while you're watching a seminar. Not good. So just avoid it. So if there is something that people really should understand when they listen to the talk, explain it to them. You're going to give a talk about the island of inversion. Don't assume that they know the island of inversion. Roy knows what the island of inversion is, right? So you explain what the island of inversion is, or make sure that you introduce. Now you can't give all the details. You have to draw a line somewhere. If you give a 10-minute talk, you can't explain the details of the island of inversion, but also the audience that is sitting there will likely know what the island of inversion is. So this is not many people do this, but actually if you, and maybe some of you did, if you're in accelerated science, maybe you have given some talk for some review for FRIP related stuff. The title should preferably provide the main takeaway of the slide. In this presentation, I did that. The title explains what is the most important thing. Then the title is not just some word, I could have made this title of the slide and it wouldn't say anything, right? So this is very detailed. How do you capitalize the title? If you look at this, my title here, there's some words that have a capital and the others don't. But it actually follows a rule. and the rule, it's called title case. Okay, and there's a website, I linked it there. You want to use title case, which is what most official presentations at FRIP do. That's how you can check whether your title is following the right instructions. You can also capitalize everything, or you can also choose to capitalize nothing. It shouldn't be a mixture of all of it. So the title should not just be the topic of the slide, but preferably present the message of the slide. And this is particularly important for short presentation. You give your 10-minute APS talk. If you don't use the title that way, you just waste some real estate on your slide. You can just say, this is what comes out of that slide. Avoid funny titles, especially if they're not functional. People might not take your presentation seriously. Okay, so this is falling in the category of the jokes. Sometimes it's functional, but if it isn't, just avoid it. Contents of the slide should be easy to follow. That's, I think, the nice illustration that Pablo gave with the two different presentations. Now, this presentation is using bullets. It's not always easy. This is a pretty dense slide. It's not necessarily easy to follow, but the story might be easy to follow. You can consider how to flow through a slide, top down, left, right. How do people think? I think Pablo's second presentation had that nicely, where you arrows pointing in different direction. You can use animations, but use them sparingly and use them if they're functional. It also depends on the length of the talk. The 10-minute APS talk, many slide transition and so is not necessarily great. And the reason is you have to go through all these different steps. People have a minute to absorb what's on this slide. So if you give them 4 slides in a minute, they have 15 seconds to absorb each step, which is not a lot. So unless they're very simple, that's very difficult to digest. Sometimes adding more on a slide helps you make sure that you don't miss important information. Actually, I do this quite often. So if I have to give a long presentation, I want to make sure I don't miss anything, I make sure it's on the slide. That means there's slightly more bullets on the slide. It's okay. At least I won't miss something. And so the bullets should be functional and give structure to a slide. Generally speaking, less bullet is probably better. This one is a little bit more. I also think this is something I might hand out to somebody to just use without me talking to it. So you want everything to be on the slide. And it's certainly possible to give a presentation with fewer or no bullets, as Pablo just showed, but this requires experience. So what is on the slide? So FRIP has a template you can use. That doesn't mean it doesn't need work. Sometimes you have to use the template. As Pablo said, you can also talk to your advisor. But if you use one, it doesn't mean there's no work needed because some logo might not be on there. If you're not sure which logos to use, please ask your advisor. In general, any standard features added to a slide, so that the standard FRIP one has a bar under here. I don't like it personally because it takes away a significant portion of the slide. and it doesn't really add. I mean, after slide 1, they know that I will work at every. Why do I need to put it on every slide? Use a simple and bright background. White is probably better. I used to like very light gray for a long time, just to make it a little bit less bright. Sometimes people use section number in a PowerPoint. I really don't think that's necessary, but what is important is the slide number. Because if people have questions, they can just say on slide 16, I have this question. If you don't have the number, then you have to go back and forth. Even with the number, they typically have to go back and forth. So on this slide, paw print here. We had a job applicant a long time ago, and job applicant, I don't remember what it was for. Anyway, on every slide, there was a picture of a cute animal. Okay. And at some point, everybody was just wondering what was the next animal that was going to pop up. Completely missing the message of the presentation. It was not helpful. Sometimes you can do something to attract attention, but it was really distracting for that presentation. I don't think the person got the job. I'm not sure it was due to the presentation. So I strongly advise you to invest in learning a program that assists you in making good figures. I use Illustrator, there are other programs. You can ask what other people in your group use because you often share figures and information. Avoid using PowerPoint itself to make figures. It lets you make animations and stuff like that. And it can be okay, but if you really want to make a complex figure, it's really not good quality. Unless absolutely necessary, do not capture and paste figures. The nice high-resolution neutron star picture that was mistaken for an atom is a good example. Actually, I have 3 here. These 3 are actually very similar. Which is the better one? So the left one is the original figure. The middle one, I forgot which one. The middle one, I'm quite sure this was a screen capture from, I actually can see the line at the top here. This is a screen capture from the website. And this one is a capture from the PDF file. You see it's a little bit fuzzy. And this is the original file right here. Okay, so you want the left one. So make sure that figures have sufficient resolution. You often scale them, and then if you don't have enough resolution, it looks bad. Choose your colors carefully so that's readable. Make sure the lines are thick enough. And often the formats of figures that appear in papers are not really great for showing in presentations because the font sizes and stuff like that. What I recommend to do is if you use a program to make figures, many people here use Root or Python. I use Paw, I'm a little old-fashioned. Make sure you have a good script for making your figures so that once you have developed it, you just change a few things and then you have a good figure every time. And then, force yourself to use that figure even if you give a presentation for the group, for example. So very important. Almost at the end. So clear and concise summary with conclusions. So restate the main message you would like the audience to remember. If you give a very short talk, like an APS meeting, you sometimes run out of time, and then sometimes you pop up the slide and say, okay, I run out of time. That's okay. But if you have a 30-minute presentation, you should really make sure to go over the details and the what you want the audience to remember. That doesn't mean you have to restate all the main points. If you have time, that's great. Provide an outlook if you can. Acknowledgement, make sure people are on there. Be inclusive with the acknowledgement. So painful if you see acknowledgement and somebody's in the audience who really should have been there. It's sad, that's how you lose friends. Yeah, so being on the side of inclusive is really important. Clearly end your presentation with a thank you, request for questions. And the acknowledgement slide, again, for short talks, you don't necessarily have to go through it. You can, but it's not the most critical. It's important that you show it. And that's what I had prepared. So any questions? So I think that's the basics. If you get that right, then you're far along. Yes?
Where exactly do we get the Fripp outline talks?
Oh, that template. We should send it around again. It's not easy to well, it is easy to find once you know it. I think we should send it around.
We'll send it, and my slides and Remco's slides will be available in the Google Drive folder that we'll share, so you will have access to all of these things. We can put the template in there as well.
Yes.
Just a comment, maybe it would be good to provide also a template similar to this one.
Mhm.
Because I agree with you that the one that has like the Epic logo and the address and everything on the bottom is horrible.
Yes.
And many people think that you cannot change it. So
Actually, the template has both versions in it, although the version that has the white space doesn't have the text automatically there. So it's a bit annoying. Yeah, as I said, I didn't use the EFRIP template for a long time. Actually, if I give a seminar, that is, I usually don't use the EFRIP template. If it's something formal, yes, you have to, and you really have no choice. Actually, if you give a formal presentation, like for some review or so, there are people in the building who literally will sweep your presentation. They will fix the title and they will do all this stuff. But it's taken very seriously. That presentation is looking as it should. Yes, there was another question somewhere. Yes.
When you were talking about making sure you have, like, the overlay or laptop got the presentation, what do you mean by having a complete presentation?
So that the thing is ready. So if you are still working on your presentation before you leave for wherever you give the seminar or talk, it's not done yet. Something happens. Now you're scrambling to finish that presentation. That doesn't mean if you have a complete version, you can still work on it, but at least you have something that if anything fails, you'll still have that presentation. You won't be stuck. Oh my goodness, I lost it. I don't know. I know many people who have been in a situation where they wished they had given they had a complete presentation.
Or something comes up and say, oh, can you present today instead of tomorrow?
Mm-hmm.
Exactly. Yeah. Exactly. And even if the laptop doesn't break, you might need a presentation earlier.
Just as a comment, life happens. You might have a call from your best friend that their dad died, and they need emotional support, and you're going to spend the entire afternoon talking with them on the phone. You would prefer to do that than preparing your slides. If you have a complete version, that is something that has happened. So be ready, and then you add details after.
I used to be able to work fine in the plane. I can't anymore, but I used to be fine to do that, but it's just dangerous.
Just a quick comment. One of your content said that the title of the slide would be effective. So in our group, we are pushing that there is a title and there is a subtitle, it's with smaller format, which kind of one sentence explain what is the outline overview of the slide. So that is.
Yeah. So this is one way to do that. To have a subtitle. I sometimes use subtitle. I must say I didn't do this until more recently. But if you do any review style things where every slide needs to answer a message, often the charge number is on there, then you want it very clear. Some talks it's a little bit less, necessary, I would say. But yeah, it is nice because otherwise the title has really no good function. You can actually use the title to make your main point. People, it's not always easy for people to follow everything you're saying about a slide because sometimes they might just not be aware of some things. You have to at least see the title and get the main message. That's helpful. But yeah, subtitles is another way of doing that. Okay.
How many, general comments on particular talks, for example, theoretical talks where formalism is quite a heavy component of it? Do you have any components in trying to communicate theoretical results?
Yeah, I think here the audience is very important. So if you're giving a talk, say a theory seminar, there's probably some expectation, and it's okay to give some equations because it's very hard to give some details without showing the equation. So for that audience, it might be perfectly reasonable to put up the Schrödinger equation and explain some of the terms that you have in there because it's a language that everybody will understand. If you're giving a seminar for a more general audience, or even a seminar here where there's experimentalists, accelerator physicists, you put a lot of equations, you lose a large fraction of your audience pretty quickly. everybody kind of maybe knows what a Schrödinger equation is because they've taken a quantum course. But, you know, to be honest, if you put a Schrödinger equation in front of my face, it's been 20 years ago since I looked at the Schrödinger equation in any great detail, right? So it's not, so I think it really depends on the audience. Certainly there are situations that's perfectly fine to show an equation. Just make sure that you understand when that is. And it's hard to explain something. Sometimes it's hard to explain things without an equation. I think in general, it's bad to have a slide full of equations, even when you give it to a specialist audience, because it's just hard to walk through it. Because often what happens when there is a complex, so you have some equation that describes a model, there's some parameters in there that are critical. Do you really need to show the whole Gorey equation? No, you need to explain the coupling constant that you use in that equation or some scaling parameter that you need. Maybe you don't need all the Gorey details.
You can focus. You can show the thing and say, like, this is the equation, details don't matter, and you preemptively tell the audience, don't try to digest this whole thing. I want to focus on, you see this parameter in terms of this spin orbit couple, that's what we're going to be talking about, and that is important. That is a kind of middle ground. Right?
Okay.
I have one quick comment is that, especially for short talks, usually the person who is the head of that particular session describes, you know, this person is going to talk about this topic. So is it, of course, and this is the same kind of information that is there in the title slide where I'm discussing this is the topic, and I'm this, I work here, but this is already described by the session chair. So is it okay to directly go to that, because that 30-40 seconds might be helpful describing the concept?
I think you can. I would say this is on a case-by-case basis. If you don't have to repeat information that was just mentioned, I guess. If somebody already reads the title of your presentation, I guess you don't have to read it again. So yeah, I think that's sort of case-by-case basis.
Thank you. Thank you, Remco. You had a lot of questions. The audience was engaged. Yes, please.
You mentioned like be mindful of like the color palette. So do you guys have like good resources for like colorblind friendly color palettes with Python and Root, and then when to make the decision between using colorblind friendly colors versus maybe doing like a design and patch them?
Yeah, I mean, it's a very good question. And actually, I think there's going to be a lot of effort to make all the presentations that are used in classes to be accessible. I think in general, it's good to try to use a combination of both patterns and colors if you can. It's not always easy, but I think that's the best thing to do. And you know, in many papers, but things get printed black and white, it's anyway a good tradition to try to use that. It's another reason to be a little bit careful with backgrounds. They're very colorful because not everybody will experience them in the same way. So yeah, I think being conscious about it is the first step. And then using a combination of patterns and colors is probably the most helpful thing.
There are websites that can transform figures, and I don't know if PDF, into colorblind vision. So you can put a plot and see how a colorblind person with different conditions will see it. Right.
Two things. One, for the grad students, wasn't there a wiki for grad students at some points that had a bunch of resources?
Yes.
This video and then templates here also be uploaded to that grad student wiki.
If you tell me where they are, yes.
Yeah.
I forget who's in charge of that. I forget with FFGO or someone.
Yes.
Let's make it happen. The video, I will put it in my YouTube channel, and you can subscribe and
The
make it
wiki
famous.
is a little outdated. Actually, I looked at it this weekend. Yeah, now we can certainly put it, and actually an older version of the template might well be there, I suspect. Yeah.
And the second question I had was, you mentioned Adobe Illustrator. Are those free resources that we can use through the university, or?
Adobe is not.
Adobe is not. So it depends. So that's why I say you have to talk to your group. So I'm not saying that's the program you should use. It's just the one I've gotten myself used to working, and it's also not the easiest program to use. I think the other thing, having good scripts to make it figures is probably more critical. I mean, especially when you have like data figures, you know, that I think having good scripts in Root or Python is really save yourself a lot of time. But some kind of graphics program, I think, is good, because using PowerPoint, is not great.
So Inkscape is just like the same thing as Adobe.
Inkscape?
Yeah, but it's the same thing except it's open source, so it's free.
Yeah,
Yep.
Yeah. There's also, this is all GLE. It's kind of like LaTeX for figures. I don't know.
Nice. We don't know it. Okay, friends, we have 20 more minutes. Let's go to the final part of the talk, and then we can have more questions. This has been excellent. I have been having a blast so far. Okay, next levels. This is the way that I want to structure this part. I'm going to be talking about these 3 sections: how to structure the message, how to make the slides, and how to deliver the presentation. And I really want you to remember the disclaimer. Some of these things are choice of style. If that is something that you do not resonate with, that's completely fine. So that figure is going to stay on that top corner, so that every time that you see something that you're like, I'm not sure, that's completely fine. These are things that could be useful for you. Okay, let's start with structuring the message. I want to acknowledge my mom for many reasons. She's my mom, she's awesome, but she's the person that taught me how to do most of the things that I do when I present. And a big portion of that is how to think in this structured way. It's a pyramid scheme, but a good one. This is not a bad one. And it's called the Minto pyramid principle. And the main idea is thinking, what is the main message that you want to convey, to think, to go through? That is the thing that is on the top. And what are the evidence or the ways that you can split that message? That is what comes in the next level. The further down you go on the pyramid, you're going more and more specific, less abstract, but then that is more detailed. And every time that you have a division, the 2 or more divisions should support what comes on the top. So for example, in this case, I made this to explain the message that I was going to convey to you. Remember how to make an awesome talk, these 3 things. And if you go in this one, these are the things that I'm going to talk, including the pyramid structure that I'm talking right now. So it's kind of a fractal, it's cool. Inception, but for talks. Why is this important? Not only helps you to structure what you want to say, but you see, as you're talking and time goes by, if I am more than halfway through my time and I'm still here, that's bad, because that means that I have to then do this, do all of that. It's a way of deciding, then if I already screw up in that way, I'm only going to go up to this level and this level in details in the next steps. And funny enough, I made this as an example, but then as I was making the rest of the slides, I keep coming back to this slide to, what is the next thing that I wanted to talk about? Anyways. Okay, outlines. As we mentioned, I think they're extremely useful in basically any talk that you're going to give. If you're going to give an hour talk, I think this is something that is very important to give. If you're going to give a 3-minute talk, I think it's even more important, because then you tell the audience, and it sounds counterproductive because you're going to spend half a minute talking about what you're going to talk about, but that gives the audience, like, this is the map, this is where we're going, buckle up, grab everything, and we're going to basically rush through it, but they already know what is the plan. And this is an example. You can have different styles. I am known for my cartoon styles, and I try to make an image for every one of the bullet points so that they can have something associated with it. You don't have to. This is an example from the good talk of today, completely formal, but an outline nevertheless. This can help you as mileposts. So as you go through the presentation, 20 minutes have passed, the audience already forgot what the heck you were going to be talking about. You stop whenever you finish this, and you say, well, we have talked about this and that. Now, I'm going to talk to you in this case about dimensionality reduction. This is where we are, and then we're going to move forward to something else. Then you close with takeaways, exactly as Remco says. You tell them what you're going to tell them, then you tell them, and then you tell them what you just told them. Takeaways are extremely useful, and you can use them also to give a more general message. For example, on the left, that was a talk that I was giving about machine learning. And one of the takeaways that I wanted to give to people is that it's something that can be used to include more people in the workforce that we're trying to develop. These are the examples of the takeaway of the good talk. Relevant and simple. The thing on the right is awful. Look on the left. That's what I was saying. I made this concept relatable. If you have never been work in nuclear physics, at least that is something that you can be like, oh, okay, that is a concept that makes sense. the part of the motivation. Why is this important? So if you're presenting a result, you're working on a theory. Where are you, Erica? You're working on a theory that is extremely abstract and math and all of that, but you give a context. Why is this important? I'm trying to describe fission for the recycling part of the art process. Instanton and trajectories and all of that details comes after. In here, what I wanted to mention is that this code, and we already talked about this is not relevant, this is not relevant, this is not something that is adding. What is on the left is something that is actually adding to that. Okay, on the slide making side, graphic identity. This is awful. This is something that these two were on the same presentation that took 3 minutes part. Compared to this, you might not like the style. These are taken from one of the presentations that I have given, but you see that every slide, even though they have different parts, they belong to the same story. They have the same style. So that concept is called graphic identity. Now, everything that I'm saying are not rules. You can be a jazz musician and say, screw it, I am going to change my style every different slide, and maybe you can pull that off. So if you find a way of doing that, fantastic, explore. This is more like a guideline. Division and edges. This is also a taste thing. Both are awful. So I didn't want to change anything but the edges of the figures and the font and the background. On the left is the original picture that you saw. On the right, I restructured the locations of the figures a bit and I gave them edges. At least I like them because it's a way of dividing concepts. It's easier, I think, for the audience to be like, you read this, you stop, this is containing its own thing, then you go to the next part, etc. So that is something that at least makes it look, in my opinion, less awful. This is an example of one of my own presentations. This is my actual presentation, and that is removing all the edges. This is extremely busy, but if you see that if you put it on the left, it's like, what is this soup of a mess of concepts that I cannot even guide somebody to? Images. There is that tool. Sorry, question? Somebody wanted to say something? No? Yes? Okay. Images. There is this website that I use a lot. Basically allows you to remove the background of an image. And you can use it to make cool things. For example, in this one, when I'm trying to explain nuclear theory or nuclear physics in general, the first thing that the students see is the chemical periodic table. And then I say, but this is not enough. And the nuclear chart appears. And you see that it merges with the chemical chart. That is nice. And it's something you can achieve with that. You can even put your favorite characters in your presentations. This is Vitek. I took a picture of Vitek giving a talk. I removed the background, and now he's in my slides. These are aesthetic things. I really like that whenever I say Y theory, the atom appears and the electrons are kind of forming in a stylish way with the title, so I didn't have to cut the title. Otherwise, if this was a picture that has a white background, I lose the Y theory. But in here, it's like, looks pretty. AI. We had a huge discussion about whether or not to use ChatGPT on things. I don't know if you were present here. That was last year with Jaydeep and Kyle. And I was the one that really likes it. And one of the reasons why I say that I like it is to generate images. Examples of where I have used this, and you can do this. I think the free version of ChatGPT maybe already is able to generate pictures, but if not, if I know one of these tools that can do it. The one on the left, I wanted 2 people playing chess to explain something. The original picture that I had was from the Queen's Gambit in Netflix. And then I thought, I'm going to run out into copyright problem if I keep using this, especially if I record it. So I asked ChatGPT to make a drawing, and I liked it, and it was nice. This one. And here, I'm explaining principal component analysis, singular value decomposition, doesn't matter. We came up with this concept of the principal component doctor, PCA doctor, to explain things. And as I was trying to explain it, I wanted to make it a character. And because of implicit biases, me included, if I think of a doctor, the first thing that I think is a white dude in a white coat. And I thought, well, this could be a nice way of breaking that, making the audience think a bit why this is what you think. So I wanted a black female dressed as a doctor to represent the PCA doctor, but I wanted a cartoon. I didn't want a real person because that's my style. I couldn't find that on Google. If you search, I searched for drawing of, nothing. I made it with ChatGPT, and now it's there. The one on the left, I wanted to explain about inclusion and breaking the barrier. That is something that I couldn't find either on the web. I was able to make it with ChatGPT. And finally, the one on the right is something that I made to explain one of the research methods that we were developing to try to distinguish between similarities between models. I like the goats, I like my cartoons, but I found that this is one of the pictures that is extremely powerful in my talk to explain the concept. Basically, I'm saying you have theoretical models, and you have 6 models, but actually you have 2 types of models. One, and then the other one that is basically the same thing in different disguises. And what we're trying to do is using principal component analysis to identify what are the principal modes of these things, the hat, the glasses, etc. I explained that using this, and most people understand me immediately. It continues to be in the style of cute cartoons that I have. I wanted to highlight it as one of the good things that you can take out of here. Animations and transitions. This is a funny one. This is a presentation that I gave whose main title is called Less is More. The subtitle is Dimensionality Reduction for Accelerating Uncertainty Quantification. And when my friend Edgar, I gave these slides to him, he opened it and he was like, Pablo, you have a talk that is called Less is More, and you had 142 slides for a 35-minute seminar. What the heck is wrong with you? The reason why this happens is because one of the things that I do, the animations, I make them in PowerPoint. Every transition is a different slide. And I made that so I can save them in PDF. Let me show you. This is an awfully busy slide. If you show this to anybody, you're going to cause them a mental breakdown. But this slide comes to be in this way. I first say, we have the cycle, the theory experiment cycle. You have the chart. Let's say that you focus in astrophysics, and I'm using this white kind thing veil to tell the audience not to focus on that part. If you focus in astrophysics, you have the R process, and in the R process, you have many quantities that you're interested, masses, finding energy, we talk about that, and then you have different models, and then I continue doing stuff, and the slide closes in that way, highlighting that if you have all of these things, it's really hard to combine in an Bayesian way, etc. The main point is all of these transitions, if you want to save your presentation as a PDF, PowerPoint doesn't handle that well. So I usually have way more slides than I really have because this is the thing that I'm doing. And I'm presenting it as one option that you could follow if it's something that you think could be good. QR codes for showing the people the materials and the slides and for recording. So this is the outline for the ChatGPT discussion that I was talking about. We put the slides so people were able to access them afterwards. That way you can also put a bunch of details that you might not want to share at the beginning, but somebody that is very interested might want to go through them if they're in the extra part. But no, because I recorded it in that exact same way, I was able to put it in YouTube. And now people can go and look at the presentation. And this helps in many ways. One, it gives the audience additional resources, as I said, with the QR code. It can become part of your virtual CV. So if I was applying for jobs, I'm very happy working here with Remco, so I'm not applying anywhere. But if I were, one of the things that I will do in my CV, I will say, have you seen me giving a talk? Here's a talk of me giving talks, and I put the link because I recorded myself. And that is a way of selling yourself. And it's an effective use of time and energy. If somebody comes to the group and they don't know how to give talks, we recorded this so I can give them to them and at least start there. Hi, future people. Successful delivery. There are many things that we could talk about this, but I'm going to focus on a few. The timing. How do you time yourself well so that you don't go over time in your presentations? I'm going to divide it into local and global timing. Local is the speed at which you are talking, and you will realize that many people, when they get excited, they tend to start speaking very, very fast. I also speak in a higher pitch when I get very excited. I'm exaggerating right now how slow I'm talking, and you see that you're not getting infinitely bored. You're still following what I'm saying. So if you are one of those people that feel that have trouble speaking too fast, I recommend that you practice this. You practice this by yourself first, and then you do that with an audience of friends, and you see that you're not boring them to death. You're all still paying attention to me, even though I'm talking slow. Practice that. That should help. Okay, coming back to the original speed. Global time, one of the things that I try to do, I cannot because my phone is there, but I have a phone with a stopwatch. And then I know I have 20 minutes for this. By minute 10, I should be more or less around this part of the slide. And if I am not, if you're taking in the pyramid scheme, if you stop taking the details, stop going so far deep underground on the concept that you're going to explain so that you arrive, let's say, minute 18 to your conclusions and takeaways, so you can take 2 minutes to breathe and tell the audience the most important things that you wanted to do. This is a good practice thing that I have found out. You have a 30-minute talk to give, finish your slides, you're practicing 3-4 days before. Can you give the talk in 3 minutes instead of 30? What if you do it without slides? Just sit down and tell me, what is your research about? Well, we actually measure this thing and try to do that. Then try to do it in 5 minutes. Try to do it in 10. After you have done that, the 30-minute amount of time, it seems infinite. You will be able to go through it and have a much bigger control. Voice and contact. In case you have trouble, for example, not projecting your voice very well, and you feel that you have fantastic slides, but people cannot really hear you because your voice is not reaching out, there are some techniques that come from people that do acting and public speaking that you can follow. I put a video in here, and I asked my mom to actually send me a list of things that I'm going to share with you after. But this is something that you can practice. And I will talk about this in a second. This is a skill. These are things that you can develop if you practice them enough. Try to make eye contact with the audience. Try to look at them, not look at only your slides. Of course, if you're following your slides for guidance, it's hard to just look at the audience, but at least for me, when you're at a very advanced level, the best presentations that I have given, I kind of already know what the next slide is going to be, so I just pass it. In this case, that is not the case. Yes, and I can continue having eye contact with the audience so that it really feels like you're telling a story. You're really connecting with them. You saw how awful it felt when I was doing the bad talk and I was just looking at it. This is my previous to final slides. Practicing in general, yes, that is the answer to that thing that is not even a question. I don't know if you have heard about the growth mindset, but if you have not, Google it. There is podcasts and resources about it. It's a fantastic thing. It's a difference between thinking, I give fantastic presentations according to Remco because I had an innate ability. And if you don't give good presentations, you will remain like that forever. That is not true. I was not giving great presentations when I was at your age. It's something that you actually can practice and it's a skill. Try to record yourself. I really think that is useful. It might be painful, but no pain, no gain. It's the same thing as going to the gym. Try to give your presentation without having slides that can tie these things, as I said. Try the same talk, but with different audiences. If you have a DMP talk, can you give that DMP talk to your mom, to your friends that don't know physics, to your dog? Try to give that a go, and it might be a way of simplifying the explanations. And the final thing that I say in here, if you think this is useful, I will be more than happy to schedule a practice session. We can email, think about it, fill out a poll. It could be this time, not next week because it's spring break, but maybe in a couple of weeks. And if you have already a presentation that you want to practice, we can do a 10-minute per person. We all sit here together. I will bring more snacks, and we give feedback time in real life. If it's something more prolonged, I think Remco and I will be more than happy to have one-on-one meetings with you in the future whenever you feel ready to present a talk. So these are the takeaways. I will classify them in 3. The most important one is develop your style. Remember the manifold of presentations. There's many ways of giving a very good talk. The second one is try to identify what are the areas of growth. What is the most crucial thing that you're struggling with right now? I make very good slides. I have very clear messages. I just go on a tangent and I spend 25 minutes of the entire 30 talking about details. Okay, that is the next thing that then you should work on. And grow them by practicing. This is a skill, so have a growth mindset. With that, I'm going to give the thank yous. Obviously, I'm not going to thank Remco because he's part of the speakers, but I want to thank Magda, who was extremely helpful in helping me designing the posters and in other parts of this. Tabitha, that helped with the logistics, and my mom, because she's awesome and she taught me a lot of these things. And with that, we are done. Questions?
So I know you talked about the actual global TAM and how you kind of going in decide, okay, I should be around this slide at this time. How is it in practice if you're not kind of following you're too slow and then you have to skip slides? Is that a good thing you should do, or what should you do to kind of get back on track?
Mm-hmm. If you have the pyramid thing very clear in your head, what is the main message that you want to give? So for example, let me give it to you in a specific way. It has happened to me. This is a good one. I talk about myself. I give an introduction to Bayesian statistics and machine learning, dimensionality reduction, these 2 type of approaches, which are filled with 10 projects each, and then takeaways. I should be by half the time in here. And it has happened that in a 20-minute talk, I am here by minute 13. Then, trouble. I acknowledge that, and I say, okay, I'm running, I am a bit behind time, so there are some things in here that I'm going to skip. And I don't rush the slides. That is a bad idea. You cut. You say, I'm going to explain briefly what this is, and it might even be that we're not seeing slides. Model error reduction. Basically, what we're trying to do is ta, 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 ta. That is a basic idea. I have beautiful slides that you can look at it later if you want. I will share the QR code, but that is the main idea. Do you get it? Oh, yes. Okay, let me go to the results, and you do this. Don't look at the slide, don't look at it, look at me. You pass the slides, and then you arrive at the results, and you say, in here, the most important thing, and then you continue. So I think that's completely fine. I have acted that way with audiences, and nobody's like outrageous. I think it's a very bad idea when people say, oh, and I have the person that is in charge is telling you, you have to cut it, like, yeah, we're ready, 20 minutes. Oh yeah, okay. But switching gears, so very quickly, and then you start going super fast, just reading the thing, nobody will take anything out of that. It's the same thing that happened with the flyer. I will just read this extremely quickly to you so that I feel that I have completed everything that I had to complete. You will not retrieve anything from that. Does that help? Final thing, practice it with friends, if you can. If you can, give the presentation to a group of friends and make that happen on purpose. Like, assume that you were having 20 minutes, but then somebody cuts it by 5, and you have to finish in 3. What are you going to do? Okay. Then I'm going to switch gears in this and that way. Does that make sense, Pranjal? Excellent question, thank you.
The other thing, which is, I didn't used to do this until recently, but with a 10-minute talk, it's hard. But a half-an-hour talk, aim for 25 minutes or 20 minutes. Nobody's going to complain if they get to the coffee faster. Right? So if you finish early, it's fine. So just make it shorter. I started doing this, and you get tired of yourself hearing talking. Just make the talk shorter. That's fine. And then usually you'll take a bit more time than you expected anyway, and then you're still well within. I think that's a good strategy.
Less is more. Aim for 140 slides. Eric.
Just to comment, the rule of thumb I usually have is everyone will complain if your talk is long, but nobody will complain if it's short.
Yep.
So.
Yep. More questions, comments, please.
The background of full lighting is, do you ever find that it actually reduces the image quality though, like the compression and everything?
For me, no. Look at Vitek. He looks happy. Look at the chart. You can even see these isotopes. So, no, not at all. And that's why I put the website in there. It's the only one that I have found that is free and this good. Daniel.
For what it's worth, a lot of tools like Illustrator or Inkscape, they'll also let you remove the background. And I think those are generally not reusable.
PowerPoint also has a background remover. It's not great because it's automatic and you might have to go and clean it up, but it's very simple, like for VTech, it probably work very well.
Very good. Thank you. I didn't know that.
Yeah, for something more complicated, it's not.
Very good. Right.
Hey, something I haven't heard was whenever you're speaking to a room full of people and you're actually told to look out and not look at your slides, what do you look at? Do you look at everyone? So something that at least we practice is having a few anchor points in the audience, like maybe 2, 3 people or 4 that you look at. That way you don't look at one person the entire time, but you scan across as you're looking. That makes it seem like you're looking around, but you're looking really only like 4 people.
Yep.
That kind of helps for me too.
Looking at your slides is not a bad thing. The problem is fixating on your slides, like doing this and just passing by. But yeah, that works. You should look at the people that are looking engaged. If somebody is like, and you look at them, you're going to feel very bad. So you just ignore that entire field completely. But very good points. More questions and comments.
Just following up on that, I heard that if you look at people in their forehead, it seems like you're not looking at them.
Do you feel that way when I'm doing it right now? Huh?
Preference, I guess.
All right.
I get nervous if someone looks at me in the eyes and starts talking to me very seriously.
I see. Yeah. I guess if you fixate on a person, that might be bad. Okay. Yeah. You should try it. You can practice with each other. You can give practice talks and be on the audience and the receiving side and be like, yeah, I felt uncomfortable that you were looking at my hair the whole time.
Okay.
Or not. More questions and comments. Curtis.
One thing, I guess it's more common than anything else, but something that I found when I'm practicing for I'll hit like a slide, and I just kind of like stumble on that slide like every time I practice it. I'm like, okay, there's a problem with that slide. I need to figure out how to fix that stumble.
Yep. My recommendation would be, what if you remove it? Do you lose something because it might be?
Not being reminded to myself there that
Yep.
I keep forgetting.
Yep.
Or is there something in the flow that's messing up? There's something wrong now. You need to figure out what that is.
Yep. I have found that myself, especially when I am giving that moment that I told you, like I gave this talk. I think it was the DMP one in Hawaii. I didn't have to look at the slides. I felt so great, and it was like, I remember practicing for talks in where I will always get stuck in the same place. That means that flow is not flowing. And then I remove it or I change the way that I was saying it, and it's like, okay, now it feels like a story. It feels that it makes more sense. Yeah.
So you mentioned like having your own personal style. What if your style doesn't reflect what your advisor style is, and how do you mitigate those differences?
In here, I'm very glad that Remco is here because he will be able to actually give you advice that is useful. I will say, burn the place to the ground and do whatever you want. But I don't think that is great. So Remco, what do you do in that situation?
Yeah, I think you obviously want to listen to the advisor because it might have some meaning. I think it depends a little bit on how flexible people are. So you kind of have to test the waters a little bit. I think if you're making your presentation for some meeting and you do some template or whatever, unless that person starts complaining about it, it's probably fine. As far as I know, most faculty are pretty, and we actually have had discussions about it. I remember at some point for APS meetings, we would tell the students everybody should use the same template. And I personally didn't think that was a great idea because it was not impersonal. They kind of posted it all the same. I know why that was done because it was, good to show that there was a presence of lab there. So I think it's just, like many things, it's just good to have a conversation about it. Maybe before you put in a lot of energy making your own slides. And there are certain occasions where it's really important to use a template or to stick to certain rules. And I do think, if people have experience, they will also be helpful to warn you about certain things. I don't have much experience. I had one experience with one of the first graduate students that worked with me, and I'm not very critical in terms of slides. And that student had a slide in it when the then lab director saw it, got very upset about it, and it was because some sense it showed a broken part of the cycle. Not happy at all. And I didn't catch that sensitivity. I wasn't more careful. So it's good to ask people. People have some experience, what might work or not. I think in nuclear science, most faculty are okay with students use their own template, but they can probably also give some good advice.
Even more nuance exactly on that topic, you might feel that this is your style. Seriously, like sometimes advisors stubborn. Sometimes they just literally know more than you, and you might feel that this is how you would like to present because this is part of your identity, and the advisor is telling you it's not going to land well. It's not going to land the way that you're thinking is going to land. So it's a balance. So I said the first part kind of as a joke. I am very easy to get angry if something like that happens, but a lot of the time there is wisdom in there that you will not see until you have passed through it. So also appreciate the fact that they're looking after you. We should kind of cut this up because we said 45. Is there any last minute question before I send everybody home? And if anybody wants to ask more, Stace, final room for urgent question? Going once, going twice? Okay, thanks everybody for coming. This was a pleasure. This was excellent. Thank you. Bye, some people.